All right. Welcome back to the daily dose of LeetCode. Here doing daily LeetCode live streams at 6 p.m. Eastern time. Hopefully we got a couple more people watching today. There's a couple settings I tweaked. The last stream I did, I believe it was yesterday, but time goes by so fast, sometimes I forget. Yesterday we had some issues with our stream, but I did some research and tweaked some settings, and hopefully this time we'll get something good. I'm really excited about that. That's going to be the best thing that we can do. So, a couple things I want to talk about in today's stream before we go directly into our coding like we always do. So, I started a website. This is something that I've been thinking about doing for a while, and I just wanted to create a very lightweight website that would allow for people that watch the stream to sort of have a way to track their progress. Right now, you can't really track your progress, but the main reason I created this website was for a particular reason. So, we've done a lot of questions, right? We've done, as of now, we are at 143 questions. Now, not all of these questions are top quality questions. Some of them are better than others, and of course, some of them are really bad. And you can find a lot of these in the lists, like top interview questions or top 100 liked questions, or maybe even other lists like LeetCode or Blind 75, so on and so forth. But since I'm doing something a little bit different and going through every single question, I thought it would be worthwhile for me to actually just make my own list. And I literally just called it Raphael's list, like my name's Raphael. And this is what that list is. So a couple cool things about this list and things that I think are pretty neat. These all come from the LeetCode list that I created directly on their platform, directly on their website. And what I did was it was sort of like a lot of manual work, maybe, but now it was manual work the first time, but now after every stream I'll be updating this. So if you follow this website, you'll always be up to date. Pretty much it's every single question that's listed. There should be a little over 50, but the cool thing is for each one of these questions, you can actually click on this stream clip link right here, and it's going to take you exactly to the place in a stream where we talked about it, right? Because you can, if you've been following along for a while, you know that in all my streams I have all these chapters for easy navigation and also all the different questions that we cover. But sometimes it's hard to remember, like, where did he talk about this question, or where did he actually go over this? That's exactly what this website's trying to do. So if we pick some like arbitrary one, like sum of all odd length subarrays, and we click on this, right? Again, it's going to take you directly to the place where we solve that problem. Sum of all odd length subarrays. It's kind of a tongue twister. So I think it's helpful. I'm really hoping that you all think it's helpful. You can find the link in the description of this live video, whether you do it now or you want to do it afterwards. It'll always be there, and I'll make sure to put that link in the description every single time. So, if you're seeing this for the first time, subscribe to the stream, because I can promise you that I'm going to keep this website uploaded. That way you can always find the high quality questions. On top of that, of course, I added some support for like basic filtering, so you can look up different topics like depth first search, for example. You might look up something that has a heap priority queue, and then as sort of like this will kind of make it easier for you. Like, this is more like if you need hints. If you're really stuck on something, like let's say you have no idea how to do, I don't know, invert binary tree, you can click on these topics here, and it'll show you all the different topics related to this question to kind of move you in the right direction. Something else I thought that was pretty cool, and I hope you all think the same thing, was I just open sourced this whole thing. So if you go to the website, you click on the GitHub icon on the top right, it'll take you directly to the repo. And if you find a bug, or if you want to add your own questions, something you think I should talk about, by all means, go ahead and contribute. I added just a little snippet here of something to contribute, nothing crazy. I'm pretty lax on this stuff. It's kind of like my first time really doing this, but that's really the update. I might keep making some other videos about this. Like right here, I put, how to solve your first 50 LeetCode questions, where I essentially do a brief overview of that website. Hopefully it's geared toward beginners to figure out how they can just get 50 just by watching all these different videos. So without further ado, I'm glad to start on today's stream, and let's go ahead and get started. So today we're getting started. Let's see, we're still on page 2. We're hitting our 143, and we're going to go all the way down here to intersection of multiple arrays. Let's see what we can get here. All right, so we're starting off with a high quality question, which I like a lot. I think that's really great. So given a 3D integer array nums, where nums of I is a non-empty array of distinct positive integers, return the list of integers that are present in each array of nums sorted in ascending order. let's see, the only integers present in each of nums 0, nums 1, 3, 4, and nums 2, 3, 4 are 3 and 4. Okay. Nums is, so it says given a 2D integer array nums where nums of I is a non-empty array of distinct positive integers. Okay. Return the list of integers that are present in each array of nums sorted in ascending order. Okay, I see. So all of these are distinct, which means they're only going to show up once. So I think what we can do, let's think about this. Like, what if I had just taken, like, I have 1, 2, 4, 3 and 4, 1 and 2, 1 and 2. Does it really matter? Does it really matter that they're not like 1, 2, 3, 4, 5, 6? This is none. I don't even think I have to. I don't think I have to order them or anything or sort them. I just have to count the frequencies, and whichever numbers appear 3 times, in this case, we'll just return that. Now, each array of nums sorted in ascending order. Okay, so they also want us to sort that. So can we just create the list and sort it at the end? Maybe that's one thing that we can do. Something else that we can maybe do is, how many numbers do we have in here? Nums.length, the sum, one of nums.length less than or equal to 1,000. But what's like sum of nums of I.length and nums of I? I'm wondering if I can just make, like, how many numbers will I have in each one of these? That's kind of what I want to know. Oh, it'll be, so how many numbers can I fit if I add all these 1 to 1,000? Like if I do 1 plus 2, let me see that. Can we do like running sum calculator? Cumulative sum from 1 to, now I want to count all numbers from 1 to something. Running total calculator. Can we not? Adding machine. I just want to add 1 plus 2 plus 3 plus 4 until we get to 1,000. How many times can I do that? Because then what we can do is we can just create a single array. We can create a single array that's the size of however many things fit in here, right? Because sum of nums of I dot length is less than 1,000. Nums ij is less than 1,000. There does not exist any integer present in nums. Well, let's do the sorting method first, and then we'll just go. Yo, Marvin, what's up, man? Yeah, good to have you. Let's just try that out. Let's just do like the first thing I had in mind, and then we'll go from there. So let's first create. I think what we can do is we can create frequency. We can create a frequency map present in each array, 0, 1, 2, right? So we want, yeah. So what I can do is for const, I'll say like for const array of nums, and then I'll say for const num of array. Do you see what I'm doing there, right? Like we're gonna go through each one of these arrays in the larger array on the outside. So my const array is gonna be this inner array, and the const num is going to be each one of these individual numbers. So for this, I just want to do frequency of num equals frequency of num plus 1 or 1. People have been asking me about this syntax. I have a video, like a short on my channel that actually says exactly what that does. Is count frequencies of characters using JavaScript, just if you want to know why I'm doing this. Now, I'm wondering if here, can we just say const result if at any time, if frequency of num is equal to nums.length minus 1. Now, can it be at the moment? Can it be at the moment that I discover that? Or if there's another one, the array return lists are present in each of the array. Okay, no, it has to be that, right? Nums.length minus 1. Let's go ahead and do result.push num. And then return result.sort AB A minus B. This is what I'm thinking just off the cuff, right? We have a frequency map here. We take the frequency of all these different numbers, and now some of them, like 3 and 4 here, right? They appear, we're gonna do 1, 2, 3, 0, 1, 2. No, it shouldn't be length minus 1. It should be nums.length, right? 1, 2, 3. These are the only ones that are going to appear 3 times. This is a similar question to one that we did the other day. Let me run this first, and then we'll talk about that. That's 3 and 4. Here we should get an empty array, right? Okay, so let's run this. Okay, wow, that's really fast. I mean, that's 99.07, or what, 0.93% away from 100%. That's pretty nice. Yeah, like yesterday, I don't know if you guys remember, we did a question that was called count common words with one occurrence. Yeah, this one, right? And I remember that I was doing a frequency map, but the numbers, the letters in each array, they were not necessarily distinct, and that kind of threw me off. This one, you can be sure that at some point frequency num will equal nums.length, because each of the numbers in this array are distinct. Now, because of that, that's a very important piece, right? That they're all distinct. Is there any way that we can make it faster without sorting it? If we sort it, will we always have to sort it in the beginning, or like if we added it? One thing I really want to try, I want to put it inside of an array, but it says here that nums.length. Okay, so the length of this will be less than or equal to 1,000. Now the sum of nums of I dot length. Okay, so I guess taking the sum of all these will be less than 1,000. So it's like, I really don't want to do this, but like it's gonna take such a long time. How can we? Let me see something like running sum. I want to do this. If we just create, I'm literally just creating a function on the fly here to see if we can do this. Let's set this equal to some function that takes however many, let's say, times, I guess. It's like how many times it will run the loop inside of here. For let I equals to 0, I less than times I plus plus. Let's just do let sum equals 0. And I just want to add the previous one, right? So I want to do 1 plus 2 plus 3. So we can do sum plus or equals 1, sum plus or equals, oh, we can do sum plus or equals I, right? Sum plus or equals I. So 0 plus or equal I is 1, and then 1 plus or equals 2, okay. And then we just return sum. Okay, so if I do running sum of 10, that's 45. Running sum of 100, that's 4950. If we do running sum of 50, 1225, 45, 990, and 46. So like, why am I doing this? Because I was almost hoping that, like, if it says it's less than 1,000, does that mean we can only have numbers from 1 until 45? Could we do that? All values of nums I are unique. Also, when I see something that's unique, what if I take the set of this, which will give me 3, 1, 2, 4, 5. I take the set of this, which is 1, 2, 3, 4. Can I just merge the sets together? 3, 1, 2, and then 3, 4, 5, 6, or all this other stuff. This might be, let me run this again. 22.53. I think maybe we just got lucky that first time. Less than 1,000. Okay, what if we just did 1,000 then? Let's just try frequency equals new array, and we'll fill this up with 1,001. And then what we can do is frequency of num, we'll just increment this by 1. Frequency of num plus or equals 1. And then at any point, what can we do here now? Maybe we can just do this. I can create the result down here. What if I just now go through, let's see, for const frequency of, how about for const value of frequency, if value equals nums.length, that's not going to give me the index though, right? We need the index. For let I equals 0, I less than nums.length, I plus plus. Here we can do if, no, this should be frequency, not nums. If frequency of I equals nums.length, we should be able to push result.push I plus 1, right? Because it's not, 0 is not included here. Like it has to be 1, so we should push I plus 1. So 0 if it goes to 1. Or do we have to do that? Because it'll just be 1, perhaps not, perhaps not. Let's not actually do that. Let's just result.push I and then return result. Let's see what we get here. 3, 4, okay. Yeah, Java. So at work, I use C# sometimes, and I mean, C# is similar to Java. I definitely like its like robustness, and it has a lot of functionality that sometimes in JavaScript you don't get. But yeah, JavaScript's very dynamic, very like on the fly. I can get away with a lot. So I totally understand that. Yeah, perhaps trying something like JavaScript or PHP, not PHP, sorry, Python. Either one of those might serve you well. So let's see. We got the same in the test case. Let's see if this passes. Okay, still passed. And why do I like this better? Because now we don't have to sort it, right? We're no longer sorting it. We're no longer sorting it because using, I don't know if this is called like counting sort, but if we have a fixed range of values, like here it's only going to go up to 1,000, I just create this array that goes up to 1,000. And that way I don't have to worry about sorting it, right? Because the I variable here will be in ascending order. So it kind of takes care of that already. So just to kind of like maybe clean this up a little bit. I know some people really like, you know, like no braces and things like this. So let's see. Maybe I can even do something like this. Right? We'll come over here. Put that there. Const result. It'd be nice if I can even, it'd be cool to like map over this and create that, but let's submit this and try again. Okay, 91.36. I'm definitely more confident in this one, right? Because the previous, oh, sorry, I think the postman's here. That was crazy. I saw this shadow on the, I saw like a shadow on the side of my wall and I'm like, well, there goes that. So our bottleneck last time was that sort at the end, right? But since we removed the sort, and that would have been an n log n time complex algorithm. But let's think about what we did here now. So we have, as far as time, this would be constant, right? Because we're always, it does not matter the size of nums, we're always creating an array that's size 1001. So I'm going to say this is constant time. For this, I think here we see that each inner array can be of different size, right? So let's say in terms of time complexity, this is constant. This would be something like O of m by n, right? Because we're going on the outside and then per each one inside. This one's like a different size than this one, so O of m by n. And then over here, this will be, again, we're going through frequency, which is constant, right? So, because constant, I mean, this will never change. It's always going to be constant time no matter what. And then we just, yeah, so I think our time complexity here, we reduce it from n log n to m by n, which is a nice improvement there. All right, and then space complexity, really the only space we're taking is this result array, which for all intents and purposes, we can say it's linear. So I'm happy with this. Let me run this one more time. 71.3, I'm good with that. Let's see what we're getting here. Java, easy solution, counter, let's see. Yeah, exactly. So it's funny because I got this counter thing. I don't know if this is counting sort, but we can just count all the numbers. And I feel like this person, Votruback, he definitely has a lot of examples using counter. So kind of like what I was talking about earlier, like for example, this is a really good question. So what I'm gonna do is I'm gonna open up my notepad over here. If my computer lets me. Let's open up my notepad. I'm gonna put this here. What I want to do is I'm gonna like this question. I'm gonna add it to my list, but I'm gonna save it here. So afterwards, right? Like after I save all this, I can go back to my website and then just add it to the list there. Cool. So I'm really happy with this. Let's go ahead and continue to the next one. So now we have, that was intersection of, okay, so intersection of two arrays. All right. Is this just the same thing? Given two integer arrays, nums1 and nums2, return an array of their intersection. Each element in the result must be unique, and you may return the result in any order. So in this one, I almost want to, like, the first thing that comes to mind is, again, keep track of the frequency of numbers. How long are each one of these? Each one of these are 1001. So I think what we can do, let's see, I can take the frequency of the first one, then I go to the next one. If at any point, like I go to 2, and then I go to 2, and that's 0. So imagine we had our array here that was like 0, 1, 2, 3, 4, right? This is like our array. Actually, let's make it like empty slots. We start going. So 1, we have 1 happens once, 2 happens once, then 2 happens again, and then 1 happens again. Okay, cool. Right now we start going to the second one. We go to 2, so we subtract 1. We go to 2, we subtract 1. That's 0. So now does that mean that it was in both? Let's think about this, because if I go through this array at the end, yeah, I think this will work. 495, 111. Then I get to 9. Okay, I subtract 9 once. That's 0. But then I subtract 9 again. Okay, then I get to 8. That's not there. I get to 4. So even though it's once, let me see, each element in the result must be unique, and you may return the result in any order. You know what, though? I have a feeling that, like, if there's two 4s, if there's two 4s here, like one shows once and the other one shows, so it has to match up exactly. So I don't even think it needs to be 0. I think as long as it shows up, if it shows up, you decrease the counter, and then you add it to, I suppose, like a set. That's actually what it might be. And they want us to make it unique. Each element in the result must be unique, and you may return the result in any order. Okay, let's do the same thing we did last time. Let's create a frequency map here, right? Because it's 1000, so I'm going to use that to my advantage. I'm going to say const frequency again, literally the same thing we did before. Now let's go and fill this one up here, right? So let's do for const value of nums1. We'll say the frequency of value equals frequency of value plus 1 or 1, right? And now let's think about this. If it appears at least once, then I can add it to my output, but I need to check to make sure that it's not already there. It would be nice if there was like an easier way, because I really want to try and make this like a fixed size array here. I can easily do a set. I feel like that's the easy way here. And maybe we should take advantage of that. So let's say our output, const output is new set. Now let's do the same thing. We can say for const value of nums2 intersection of two arrays. Oh, nice. That's awesome, man. Thanks for sharing. Let's see what I get with you said this was Python, right? Nice. Python 3. Let's see what I get in this one. But our algorithm might be different, but we'll figure that out in a second. So for const value of nums2, first let me see if I can find it. Like, it needs to be there with a value greater than 0. So if, let's see, or maybe I should only consider it if the value is greater than 0. If frequency of value is greater than 0, then we can do, or we can do if frequency of value is greater than 0. Do I only want to add it once? There's 2, 2. This is 9. Okay, this is 4. It wasn't there. Do we just, and not output dot has value. If frequency value is greater than 0 and the output does not have the value, maybe we can say output dot add value. And then over here we return, this is not going to be like very nice, but we'll have to do output dot values. Let me see what this gives us. So 2 and 2, 294, 294. Let's submit. I'm not in love with the set thing. 55.10. So let me see. I was wondering why 1001 as well. So I did 1001 because here it's saying that the numbers are going to be less than or equal to 1000 from 1 to, like, that's the bounds of the array, each one of the different numbers. So we want to include 1000. So if I made the length 1000 and if we had the number 1000, then it wouldn't fit in the array. It'd be accessing an out of bounds index. So we just make it one size larger to be able to accommodate that. Or since we're not actually hitting 0, I suppose I can just do like, I guess I can just subtract, right? I can sort of normalize it and say, okay, instead of actually putting it in 1, put it in 0, so on and so forth. But yeah, this is a common thing. It's exactly what we did in the previous one. That was a great question. So let's see. So frequency, because the other, like, why am I choosing to do frequency, right? If I do a map, if I just choose an object literal, if you think about it, if we just think about how arrays work versus object literals, like object literals are heap memory. So when we add things, they're all located in the heap, right? But when we do like static arrays, this is all contiguous memory blocks, right? So it makes it faster to optimize. It can be optimized and it's very fast to be able to index any of these. It's actually just faster in the compiler versus like the heap memory, which is still fast, right? It's still like constant time access, but it's in heap memory and not stack. So by doing this, we can say like, well, the time complexity of creating this frequency map right here will be constant, whereas with the map, it can be like n amount of entries. Like that will grow depending on however many numbers we have in nums1 or nums2. I'm going to bed. Good night. Hey, good night, MMD. Good to see you around again. It's very cool to see recurring people join. Like I'm starting to like know everyone here, so that's very cool. And then for this set, yeah, I mean, the reason I'm using a set here is because it wants it to be unique, and the set is really the best thing at doing that. So, you know, I'm fine with that, right? Like adding numbers inside of a set. This is an unordered set, so it's just constant time to be able to add it. We don't need it to be in order. Now, here, it's all right, you know, maybe not the best thing. It'd be cool if each result must be unique. You know what we could do? I wonder if I can reuse frequency here. Right? If as I'm going through here, it can show up once. Okay. If it shows up once, and we add it, what we could do, I don't want to create another one though. I don't want to create another frequency array, because if I use this one that I have here, maybe like when I find, I can keep the frequency of the first one, 1, 2, 2, 1. And when I find this 2, if I go over here and remove 1, and then let's say I remove another one, but I would only do it once, right? For const value, and it says I can return it in any order, but it must be unique. If I was using another frequency array, I think, you know what? I'm going to leave it like this, because a set is really the best thing for uniqueness. It handles that for us, but you can see the time complexity here isn't great. I really want to get above 50. I don't think we've gotten that yet. So I don't know. So perhaps I think it's just a good indicator that you might be able to use a set, especially since it's bolded. But they're also saying it's in any order. So that's why I really want to do, because if we do, so let me show you the other thing that I was thinking, and let's just compare, right? I can compare frequency here, and then I'm gonna create another one. Just bear with me here. I'm gonna call this one like chosen. I'm gonna remove output here, and then I'll go through value of nums2. If frequency of value is greater than 0, and so let's see, if frequency of value is greater than 0, and we can say chosen at value is equal to 0, then we can say chosen at value, let's say that equals 1. So I create an array of 1001. I go through all the values in 2, let's say like 994. If frequency of value, right, this is greater than 0, and we know that chosen at value, chosen at 9 is equal to 0 because everything here. So then we set chosen of value equal to 1. So once it's set, we won't be able to set it again because that value won't be equal to 0 anymore. And then what we could do is we can create our result, or we can create our output again, and then just go literally the same thing we did before. I can do I less than 0, I less than chosen dot length, I plus plus, and we can say if chosen of I is equal to 1, then I can say output dot push output dot push I, and we can just return output. Let me see what this gives us. 249. Okay, see, so any order, right? 249. It's in ascending order because that's what that counting gives us. What happened to all my test cases? Oh, okay, is that it? Let's submit that. 51. Okay, so first time we got over 50 was when we did this way, right? $38.62. I'll try one more time and then we'll look at solutions. Wow, 14.46. Okay, 2 sets. Naive approach would be to iterate along the first array and to check for each value if this value in nums2 or not. Add the value to output. Such an approach will result in a pretty bad O of n by m time complexity, where n and m are arrays length. Both arrays into sets. Okay. Built-in set intersection. Okay, no, that's built-in. What? They're really only going to propose 2 solutions? 3 Java solutions. Use 2 hash sets. O of n. Okay. Int result. Int I0 plus num. That's pretty much what we did. Sort both arrays. Right. Okay. And log n. Or a binary search. What's the intersection of 2 arrays? You do a binary search to find the numbers. Yeah, and log n. All right. Well, this is going to be linear time. Are nums1 and nums2 equal length? No, they're not. But does 1 m by n? Or no, this is m plus n, right? Not m by n. And then plus output. Okay. Yeah, I'm not sure. I feel like the solutions are, like what we have is pretty similar to solutions. Okay, 72.55. My code was running on a server that didn't like my code. Let's go to the next one here. Find the difference of 2 arrays. A lot of array questions today. Given 2 0-index integer arrays, nums1 and nums2, return a list of answer of size 2 where answer is 0. Okay, return a list answer of size 2 where answer 0 is a list of all distinct integers in nums1 which are not present in nums2, and answer 2 is a list of all distinct integers in nums2 which are not present in nums1. Okay, so pretty much the logic is if, like, take the frequency of both, we start looping through these, right? Let's say we say, what's the frequency of 1? That's 1, so it's unique to nums1, and it's not in nums2, so we can return that. 2 is unique in nums1, but it is in nums2. Yeah, so I think that's what it is there. Now, are these both Are these both the same size? No. They're not both the same size. Now again, I'm gonna use the object literal this time. So let's say nums1 frequency. Let's do const nums2 frequency. Let's just say let's say get frequency. And here we'll just pass in an array and let's say obj. Or actually even better, what we can do is we can say for const num of r obj. Maybe here I should actually say, here we'll do this. We pass in an array, we create our frequency here. And here I'll say frequency of num equals frequency of num plus 1 or 1. Let me put this on a new line, make it a little bit easier. Right, and then here we can just say return frequency. So I'm going to do this twice. I just want to make this a little bit cleaner, right? So I'll remove both of these guys, come down here, and now here I can say get frequency for nums1, and then get frequency for nums2. Right, so nums1 frequency is get frequency for nums1. This handles, it creates an object literal of frequency, it calculates the frequency, and then it returns that object literal. So now we have it here. We have two of these for both. And now we have this piece right here. So let's say const of answer is a list of, how's it going to be? Const answer, let's just have these both empty to begin with. And I guess we can just calculate each one of them now, right? I can say for const value of nums1, and I think this is gonna be a good opportunity here for a function. We'll figure that out in a second. For const value of nums1, if nums1 frequency of value is equal to 1, and because it just says which are not present. Nums answer is a list of all distinct integers in nums1 which are not present in nums2. So we would need for this to be if nums1 frequency of value equals 1, which means it's distinct in this one, and nums2 of frequency of value is undefined, so it's not present. Here we can say answer of 0 dot push value, and we should be able to do the same thing, right, for the next one. We'll do const2 here, and this is answer 1 is list of all distinct integers in nums2 is 1, and nums1 frequency, right, value equals undefined. We'll say answer 1 dot push value. Now is there a nice way for me to abstract this, or would it be just kind of like, it might be kind of weird, right? Yeah, I think leaving it like this is fine. Let's return our answer. Let's see what we get. Is this answer 1 is 4? Okay, answer. Are we going into? Okay, I thought we were running into like an infinite loop or something. I was like, what? Let's see what the answer is. Okay, so we got the wrong answer for the next one. Let's see, example 2. Wait, but for nums1 and nums2 and for nums1 of 2 and nums1 of 3 are not present in nums2. Since nums1 2 equals, their value is only included once? What do you mean what? List of all distinct integers in nums1? Wait, but this is not, these are not distinct. For nums1, wait, does this have, or am I missing something here? For nums1, okay, for nums1 of 2, which is 3, and nums1 of 3, which is 3, they're both not present in nums2. Okay, but since nums1 of 2 is equal to nums1 of 3, their value is only included once. So does it just want it to be that if it's included at all? If nums, that is bizarre. That's very strange to me. Why these would be considered as once. 1, 2, 3, 2, 4, 6 are not present in nums2. Answer 0 is a list of all distinct integers in nums1 which are not present in nums2. So what would happen when we get to that 3? It's not equal to 1, but it's not. Okay. Do they just want for me to include numbers that are not in the other one? Is that what they want? That wouldn't be right though, right? That doesn't sound right. That really doesn't sound right. Let me try something here. 1, 3, 4, 6. Okay, 3, 3, 1, 3. Okay, so that part's right, but now this one I'm including both, right? List of all distinct integers which are not present in nums2. Okay, how about this? How about this? I really don't want to make both of these sets again. But is that the best? That seems weird. That seems weird. Let me see something. New set. Can we do this? How? New set. Answer of 0 dot add value dot add value. Okay, because now both of these are sets, and now having to return both of those is very strange. Answer. Let me see. Answer at 0 equals. I think it would be. Wait. Answer of 0 dot values. If they want me to return back an array, answer of 1 equal to answer of 1 of values, and then return answer. This seems bizarre. Not really in love with this one. New set. Okay, I forgot that piece. Okay, so this is still doing the same thing I had before with the objects, but why? Let me. Does anyone know what they mean exactly here? Like, this is saying, given two zero index integer arrays, nums1 and nums2, return a list answer of size 2 where answer 0 is like, note that the integers in the list may be returned in any order. Okay. Distinct isn't, wait, distinct versus unique. What is the difference between distinct? Unique helps to ensure, no. I just want to know, like, in general. Distinct, capable of, no. Being the only one of its kind. So not unique, but distinct. Distinct and unique. Distinct, remove the duplicate records, retrieving the records from a table. There's something I suppose simple that I'm not seeing here. Why would 1 and 2 are okay? One is in 1, 2 is in 2, 3. Oh, so it just needs to be included at all. If value of nums1, if nums1 of frequency No. Yeah. Oh, I think I see. I think I see here. I think I'm getting it. Okay, so it needs to be that the number is included at least once, not in the other array, and only added once. If we already added it, and are these are not in order, right? 1, 3, are these in? Turn the list. Are these sorted? No. But I also need to make sure that I didn't already add it. Numbers included in at least one. So if nums1 a frequency value is 0, you know what I could do? What if I check 1? Like this is 0, that's -1. I get to 1, that's -1. I get to 1. Maybe every time I get to, like if it was 3, I would still just add 1, right? I would, if there was 3 3s, I would still just add 1, because it's only, do I need to keep track of, this is also 1,000 again? Okay, yeah, I think I know what the issue is here. Maybe instead of doing frequency, and I not only need to know the frequency, or maybe it's just that we've already seen it. Can I create a set as I'm going along? Maybe I can say, okay, I've seen 1, I've seen 2, I haven't seen 3. Okay, so maybe I say loop through each if I haven't seen it. If I haven't seen it and not in other array, maybe something like this seems whack. But let's see. Okay, loop through each one. Nums1 seen is new set. Let me remove this. Let's do here if not nums1 seen dot has value. If I haven't seen it and it's not in the other one, then add it. And nums2 of frequency is undefined. Then maybe here we can do this piece. Scene. Let's just make this scene, because I can actually clear this. Let me try this out. And then here, maybe I can do scene.clear. I think clear is one of these. Maybe I can do the same thing down here. Reached in the tool belt for the set. Yeah, man. That's how it is, right? I mean, you're just like, you got to think about the tools you have and be like, well, let me use a set. The set comes in handy, man. The set comes in handy. If not scene.has value and nums1 of frequency, maybe here I'll say answer1.push value. Again, not really in love with this. I feel like I'm doing a lot. I feel like I'm doing a lot right now. That's what's happening. Let's see. Still, how did I get that? Oh, wait. I gotta add it, right? I gotta actually scene.add. I think this is gonna be it. It's not gonna be nice. It's not gonna be nice, but I think it's gonna be it. Okay, so that gives us that. Let's submit it. Okay, 70%. Let's see. I'm not convinced. Let me run this a couple times. The weird thing is, like, my initial solution, this is what, 56, was assumed, because I thought, I guess this says distinct. It's not unique. So there can be multiple, but it's just the one character. Like, there's only, like, there are 3s, but it's just like you just take one of them as like your candidate. So what can we answer, and then another set? Let's see what discussions say. Bitwise manipulation, set difference, okay. But see, I don't want to see like built-in functions. Calculate the set difference. Beautiful. Okay, first create two sets, then add nums1 element to set and nums2 to set 2. This will give you two sets with unique elements only. Now iterate to all elements of set 1 to add those elements to first sublist of result list, which are not in set 2. So I didn't even need a frequency, right? I could have just taken, yeah, so at the end of the day it was the set. The set reigns king again. The set is beast. Set really is beast. Take unique numbers from here, take unique numbers from there, go through each one, see which one's not in the other one. Yeah, let's try that out. I like this one. I like that solution. So let's do, actually, can't we just do const nums1 set equals new set nums1, const nums2 set equals new set nums2, const answer is this for const value of nums1. So if not, right? So if not nums2 set, if not nums2 set dot has value, then we can say answer of 0 dot push value, right? For const value of nums2, if nums1 dot set has value, then answer 1 dot push value. Return answer. Let's try this one out. You're kidding me. How did we get the double 3? Nums1 set, nums2 set. How is it that we're still adding the double 3 if we only have 1? 1, 2, 3. 1, 2, 3, 1, 2. Okay, so we go 1, right? Like, nums1 are not present in nums2. 1 is not in that one, so we put 1. 2 is in that one, okay. 3 is not in that one, so we do 3, okay. 2 is in that one, 4 is not in that one, 4, 6, okay. 1 is in this one, so we do 1. Wait, what? Which one's this one? 3, 3. 1 is in that one, so we don't do it. 2 is in that one, so we don't do it. 3 is not in this one, so we should just add it once. Const value of nums1. Const value of nums2. 1, 2, 3, and 1, 2. If 1, oh, wait. Iterating over a set. Yeah, we're gonna have to do, this should be nums1 dot set. That's the thing. It's not very, how do we iterate over set? Can we just do for const instance methods examples iterating sets for const item of logs the element in the insertion order 1 sum text item of set 1. Okay, so we could just do that. So I can do for const value of nums1 set and then nums2 set. We can do that. Ah, okay, nice. Oh, I learned something new. I learned more about iterating over sets. Let's see. 92.93. You love to see it, man. You love to see it. That's like incredible improvement right there. So the word of the day, and this is specifically for you, Marvin, sets are like the GOAT, greatest of all time data structure, probably. I mean, we haven't even gotten to mediums yet, and there's a whole world of data structures we haven't figured out, but a lot of array questions here. We've been doing a lot of stuff with sets. Remember to use sets if you're trying to figure something out. Okay, sweet. Now let's go to the point of this stream. Island perimeter. You guys like the ocean here? It's a relaxing thing to look at. A nice island. That was a little bit of a hint. Let's try this out. I have done this one before, but I haven't done it in a long time. So we're gonna figure it out right now. We need to go through this grid, and for every single island, I believe the island's 1 or has land, right? It's gonna be these guys right here. Although this looks like water, right? So we're gonna have to figure out the perimeter of this guy. So 0, 1, 0, 0, 1, 1, 1, 0. So let's do this, right? Let's, like we always do, we're gonna draw the grid out. That's gonna help us see a little bit more clearly. And let's see how to do this. Like, first thing I think of for this question is I know I'm gonna have to go through the whole island, right? Because the only way to get the perimeter is to traverse the entire island. I'm gonna need a way to do that. So what happens when we get to this point? Like, why does this point have, let's see, is it only if it's a 0? Okay, like this is on the border. I need to learn matrix. I've definitely skipped over it so many times. They look really hard. You know what? I felt the same way too at some point, but it's one of those things, like, I think if you just do it once, you'll become like a lot better at it. You just got to do it the one time. So hopefully this one question will get us over the hurdle. All right. So we get to the 1 here, right? This is a border, like it's on the border, so we know if, since the left is 0, the top is the border, and then this one is 0, that can be 3, right? We don't count this bottom one because that's just more land. It's not like a border. So let's say that first one, let's say we have 3 so far. Let's say we keep going. Now we get to another one. So top is 0, left is 0, bottom is 0, the right, okay, so that's another 3 that we can add, so that's 6. We get to here, we don't add anything because they're all 1s. We get to here, let's see, the top 0, here at 0, here at 0, so can that be 9? Get to this one, that's 0, don't do anything. Get to here, you have the left and the right, so that's 11. 0, 0, we get to the 1. We have 1, we have the border, and we have another border, so that's 3, which is 14. And then here, right, we have the border on the bottom and the border on the right, so that's 2, and that's 16. Now, is it really though? So 1 on the border. If we have 1, 0, let me look at 1, 0, right? 0 is, we only want to count the 1s, right? This would be, it's on the border, it's on the border, it's on the border, and then the one on the right because it's 0. Okay. I think that could be a solution. Let's try and figure it out. So let's say our perimeter is equal to 0. We're going to go for let row equals 0, row less than grid dot length, row plus plus. For let column equals 0, column less than grid row dot length, column plus plus. Now, we only do something if it's a 1. Right, so I think that's the first thing we can do. We can say if grid row of column is equal to 1, we have like a couple of different things to check. Like, if it's on the border, let me see, if it's on the border, we can always add 1. Now, what would be the easiest way to also check the sides? Because that's a lot of, I feel like that's a lot of decisions we have to make, right? If it's on, it's like we have to check the border, and we also have to check, like, if we're not on the border. Let's see, let's think about this. We're only ever on the border if we're at if we're at 0, we're on the border. If we're at length minus 1, we're at the border for both grid and column, right? And what does that tell us? Okay, we say here, okay, we're at the border. Cool. So we can automatically add 1. Let's think about this though. Because, like, do I also want to do... So my thing is, like, trying to come up with, like, an easy way for me to check all the other sides without also having to do, like, border checks. Because for everything, I'm going to have to say, okay, if I'm not at the border and the one prior to me is this, I mean, I guess we could do that. Yeah, what if we say, let me see, let's say left border, top border, right border. I'm writing this out just to make it easy for me. Left, top, right, bottom border, right? So let me open this up. So if, right, like if row if column equals 0, or grid of row column minus 1 is equal to 0, then we do perimeter plus or equals 1. And we'll go over this in a second. That's the left. What if we do, what would the top border be? If row is equal to 0, or grid of row minus 1 column is equal to 0, we'll again do perimeter plus or equals 1. Right border. If column is equal to grid of row dot length minus 1, or let's see, this is going to become a little bit weird now. Grid of row column plus 1 is equal to 0. We say perimeter plus or equals 1. Finally, bottom border. If, let's see, this would be the row, right? So if row is equal to grid dot length minus 1, or grid of row plus 1 at the same column is equal to 0, perimeter plus or equals 1. So let's try this out. I want to go through this. Like, we should go through this ourselves, right? We have our image here. We start at row 0, let column 0, and only if it's 1. So we get to our first one here. So column, is column 0? No, it's not. But column, let's see, grid row, right? Same row, column minus 1 is 0. So we do perimeter plus or equals 1. If row equals 0, which it is, or grid of row minus 1. Now, is that because of like short circuit evaluation? Well, because this, if this terminates, it's going to be undefined, right? It's going to go out of bounds. Let's imagine this will terminate early because this will be true, so it doesn't even get a chance to do this. So if row is 0, then we automatically add 1. If column equals grid, let's see, if column equals grid, no. If row, okay, so I think we already missed one because, oh no, wait. If column equals grid of row, no, it's not, but grid of row, column plus 1 equals 1, perimeter 3. If row equals grid dot length minus 1, no, and then we do, okay, so maybe perhaps this could work. I know we only did one cell, but just for fun, I want to see what this returns. 16 and 16, okay. See the next one. 16, 4, 4, 16, 4, 4. Let's submit. Okay, sweet. Wow, that's awesome. Like wow, okay, cool. Hadn't done this one in a while. Now we know, is this going to be a square? Row equals, no, so it's going to be, they're not the same, right? So we know just by default, this is going to be an m by n time complex solution, right? With constant space complexity. Now, we need to go through everything, right? We need to be able to go through everything to actually figure out. I would like to really try this recursively, where we can do almost like a depth first search, right? I'm going to continue going to the right direction. I'm going to go right, like deeply right, before I go deeply down or deeply left. And like anytime I get to a cell, I can essentially do the same thing. Could we figure that out? That would be neat. Let's try that out. The green always feels good. Yes. Oh, you mean the accepted? It does. It really does. Let's try to do this recursively. The only thing with recursion is we need to keep track of where we've been so we don't visit it again. Once we consider an island piece, we can't go back. So we can modify the grid to accommodate for that. So I'm going to do something crazy. I'm just going to delete all this. Well, actually, no, I'm not, because this logic down here is going to help us. So let's actually comment this out. I'm going to give a default parameter here. Perimeter equals 0, because we're going to return that at the end, right? So let's think about this. Maybe here we'll say also grid row equals 0 and column equals 0. So at any point, I also have to check to make sure I don't go out of bounds, right? So if let's see, if row is less than 0, or column is less than 0, or row is greater than or equal to grid.length, or column is greater than or equal to grid of row.length, we can just return 0, right? So this is what's going to help us make sure we don't ever go out of bounds, because we're going to be incrementing and decrementing these. So if it's less than 0, column is less than 0, row is greater than or equal to grid.length, or column is greater than or equal to grid of row.length. Or the other one, right, where we say grid of row and column equals to -1, and I'm going to tell you why I'm doing that second. I'm also going to put these on different lines to make it easier to read. So what is it that I want to do now? Do I just calculate, maybe I just calculate the new perimeter. Let's see, perimeter plus or equals, maybe we can say const perimeter is equal to 0. We'll just calculate the perimeter for this exact like stack frame. And then here we can take this logic, right? Should be able to take that. Let me just copy this here. Oh wait, what? What happened here? If grid row column perimeter, I think I missed something here. Let's do this. Yeah, let's copy all this. Comment that back. Let's do this. Okay. Top border, we have all our different borders here. Still accounting for those. Right, so we'll do const perimeter. We'll calculate the perimeter, which we know works from the previous one. And now really all we need to do is say, or can we just do, maybe I don't even need perimeter here. I think I just do const perimeter equals, oh, this has to be let perimeter. And then here I should be able to do return perimeter plus, and now we just call island perimeter with all the directions, right? Plus island perimeter of grid. If I want to go to the top, I do row -1 column plus island perimeter grid. To go to the right, we do column +1. Right, and then to go down, we do grid row +1 column, and then to go to the left, we do grid row column -1, and that will just, let me see. Okay, we did keep all that. I'm gonna remove this. Well, I'll cut it, right, to make sure that we don't mess up there. And let's see what happens. Oh wait, I know where I messed up. Island perimeter. So anytime I do, after let's see, after I get to one of these, right, I should make it so that grid row of column is now equal to -1. That way we don't accidentally revisit it. Grid row column, okay. Row -1. Let's try this out. So why is it complaining here? Very curious. I don't want to look yet because you can never. Is it a typo? Grid, row, and column. Grid. Am I getting? Yeah, I'm getting my row. I'm getting my column. Return perimeter plus island perimeter. Here's perimeter. Perimeter plus or equals 1. Let's see. Oh, maximum call stack exceeded. Okay. I set it equal to -1 here, so we shouldn't ever go back. Well, let's think about this. So we're going to go perimeter. We'll do whatever addition we have here. Maybe this is just going to be, or maybe we can also do, maybe it should only also be if grid of row column equals to 0. Maybe we, let's see. Okay, 0, 4, and 4. We got those right, but now we're getting, it's not liking what we're doing here. They should calculate all the previous ones, and then for each one of these, we'll have a new perimeter. And it'll just keep returning whatever that is. So why aren't we getting the 16 here? So that's good. I mean, we figured out why recursive solutions never come to mind. Iterative get the job done. Yeah, the reason I'm doing recursive here is because this is our, maybe this could be the first of its kind where we're starting to see this pattern of maybe exploring. Think of these as graphs and not like 2D arrays. It's sort of like graphs, right? And thinking about different ways of traversing it. We have like depth first and breadth first search traversal, so we can take advantage of all that stuff. I'm probably I feel like I'm close. Is it because, are we like, am I resetting this? Maybe I shouldn't be resetting this every single time. Do I need to be, like, what if we instead do perimeter equals 0 here? I'll do that. Perimeter plus or equals 1. I'll pass in perimeter down here. Let me see what this gives us. Still 0, 4, and 16. Or not 0, 4, and 16. 0, 4, and 4. So we get those right. But for me, it's trying to figure out why I'm not getting... Yeah, we're not getting the perimeter back. Return perimeter if return 0. Should we return 0 here? Or should we return perimeter? Let's see what this does. I'm also curious. I'm kind of just trying random things out right now. Okay, 0, 20, and 20. That got even worse. Unless we also say, no, yeah, that wouldn't work. For each one of these, we're always, like, when I calculate 4 here, I come back and I return that thing to island perimeter, so I can just keep adding these all together, and I get my final one. Perimeter plus or equals 1. I know it's something I'm very close to doing. Maybe we can revisit this. I'm pretty happy with having it done recursively, but maybe this can be one that we revisit as part of like a weekly roundup. So let me, the cool news is, like, all the questions we did today, super high quality questions. I really like them, so I will definitely be adding all of them to the website. So let's go easy. Let's go to acceptance here. Let's go to page 2. I think we ended up, how many did we do? 140. I think we did 4. I think we did 4 today. Yeah, we did 4. So yeah, all of these for sure. Intersection of multiple arrays. Let me double check here. Okay, I like that one. Let's add this one. I do like, well, it's fine. I think that one's good. Let's add this one to the list, and also let's do island perimeter to the list. All right, so yeah, what I'm gonna do, just in case for anyone that's watching now that hasn't already seen this, there's this website. So I'm gonna upload all these questions to my website here, so that way if you want to come back and view these and sort of like do them yourself, and you'll be able to, again, you'll be able to like click on the stream clip where we did it and get your practice in that way. I'm gonna go ahead and add all these to this website right after. So yeah, thank you all so much for watching today. I had a lot of fun, a lot of really cool things coming to the channel, so I really appreciate all the support. I feel like we've learned a lot throughout this stream, and throughout just like being a part of this cool community. I hope you all feel the same way. I'm looking forward to meeting up with you all again tomorrow. Let's see, tomorrow, do we have some fun ones? Ooh, Fibonacci number, valued binary tree, average of levels. This is all really, really good stuff here. So very excited to be able to get to these tomorrow. And yeah, like I always say, happy coding. Thank you all so much for joining the stream. And yeah, we'll see you all again tomorrow. Later.